This is lesson 8.4, sine and cosine ratios. And the last class we talked about how to use sine and cosine to find different sides of our triangle. So really quickly I'll review through that before I get to the very last example, which is the only thing we didn't do in class on Wednesday. So just remind yourself that sine of an angle is the leg opposite that angle divided by the hypotenuse. And cosine of an angle is the leg adjacent to that angle divided by hypotenuse. So keep in mind that we always use sine of an angle, cosine of an angle, tangent of an angle, equals, and then these are side lengths over here. The ratio is side length. And we remember all that with our SOHCAHTOA. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So we looked at this first example where we set up our sine and cosine ratios for different angles. And then we actually use sine and cosine to find different sides of a triangle. We looked at this flagpole and its supporting wire and saw that we couldn't use anything else other than sine, cosine, or tangent to find the height of our pole. So we used cosine because the height of the pole that we were trying to find is adjacent to your angle, and then the length of the wire, which is the part of the triangle you know, is your hypotenuse. So since you have the adjacent leg and the hypotenuse, that would be cosine, adjacent hypotenuse. So remember that it's sine, cosine, or tangent of the angle, in this case 35, equals adjacent divided by hypotenuse. To solve for x, multiply both sides by 20. And we looked at one other example like that. Okay, so here we go. New stuff, new example. That means now you need to be writing. Of course, you can always abbreviate this and put the important information. So here we go. Here's what's important. A right triangle, and that is incredibly important, has a leg 1.5 units long and a hypotenuse 4 units long. Find the measures of its acute angles to the nearest degree. What does nearest degree tell us? That means we're going to round, and we're going to round to the whole number. This sure looks like a bunch of words. So I'm going to go ahead and draw a picture so I can make a little more sense of this. I know it's a right triangle, so I'm going to start with that. Any old right triangle will do. That has a leg, 1.5 units. So pick a leg, it's 1.5 units. And a hypotenuse, the hypotenuse being across from your right angle, 4 units. Find the measures of its acute angles. What does it mean by acute angles? Well, since this angle is 90, these angles added together have to be 90. 90 plus 90 gives you your 180 total for your triangle. So since these added together are going to be 90, that means they're both acute. They're both less than 90. Since together they'll only make up 90. So what they're asking us to do is find these two angles. I'm just going to put some variables there, x and y, because I know that's what I'm trying to find. So before I even start to solve this problem, the only method we've learned for finding an angle measure is to use SOHCAHTOA. That's our only option. We can't use Pythagorean theorem to find angles. We can't use 45, 45, 90, 30, 60, 90. Our only method for finding angle measures is to use SOHCAHTOA. So let's start with x. Got to figure out which one of these to use so that I can find the measure of x. So let's look at what we know in relation to x. So in relation to x, 1.5 would be your adjacent leg, while 4 is your hypotenuse. So if we're finding x, we have the adjacent leg and the hypotenuse. Which one of these ratios would we use? Adjacent and hypotenuse. Cosine, adjacent, hypotenuse. So cosine of your angle equals the adjacent leg divided by the hypotenuse. Just like we did with tangent, if you're going to find the sine, cosine, or tangent of an angle, to find an angle measure, you have to do the inverse. So to find the measure of angle S, we do the cosine inverse of our ratio, 1 5/10 divided by 4. Let me bring up my calculator so we can do that on there. If you haven't already gotten a calculator, now would be a good time to get a graphing calculator. Keep in mind what we said was very, very important that you do before you do anything with sine, cosine, or tangent, especially if you're using one of my calculators. Before you even think about entering this into your calculator, hit that mode button to make sure that your mode is in degree. If it isn't, go over to degree and press enter. Change it from radian to degree mode. Second, quit to get out of that, and now we're ready to enter this into our calculator. So cosine inverse, that's right above cosine. So second cosine, 1 1/2 divided by 4. 1 5/10 divided by 4. And we get our angle measure, and keep in mind it said round to the nearest degree, so that would be to the whole number, and then 9 tells the 7 to go up. So the measure of angle X would be 68 degrees. Okay, that's one of them. Just knowing that one, you should already be able to tell me what Y is, since, like we talked about just a minute ago, the three angles have to add up to be 180. It's a triangle. Minus 90 for that one, so you're left with 90 for these two. 90 minus 68 leaves you with 22 for Y. Let's go ahead and use our sine, cosine, tangent to see if we can get that 22 degrees for Y. So if we're trying to find Y, again, I want to see what I know in relation to Y. So in relation to this angle Y, I've got this 1 1/2, that's my opposite leg, and then again my hypotenuse. So opposite and hypotenuse would be sine. Opposite, hypotenuse. So sine of the angle equals the opposite leg divided by the hypotenuse. Again, if you're trying to find an angle, we'll use the inverse. So to find the measure of angle Y, we're going to do the sine inverse of our ratio, 1 5/10 divided by 4. And go back to your calculator to input this in. So sine inverse, second sine, since sine inverse is right above that sine button, 1 5/10 divided by 4. And just like we predicted, the measure of angle Y is 22 degrees. Okay, we're ready to do that. Quick check. Quick check 3. If you feel up to it, I'd love for you to try these on your own. So if that's the case, then go ahead and pause the video so that you can try A and B on your own and play it when you're ready. Okay, looking at A. We're trying to find this angle right here, this x degrees. Okay, if I'm going to find an angle, my only option is to use my SOHCAHTOA. That's the only way we've learned how to find an angle of a triangle. And I've got to figure out which one of these ratios I'm going to use to find x. I need to look at what parts of the triangle I have in relation to x. So the 6 1/2, that's opposite of x. See how it's across from x. That's opposite of x. And then 10, since it's across from this 90 degrees, that's my hypotenuse. So I have the opposite leg and the hypotenuse, which means I'll be using sine. Opposite leg and hypotenuse. Sine of the angle equals the opposite leg divided by the hypotenuse. And to find an angle measure, we always use the inverse. So the measure of angle X is the sine inverse of my ratio. Nothing to solve for here, just punch it in your calculator. So second sine 6 5/10 divided by 10. And we get 40 5/10 degrees. And it looks like our direction said to round to the nearest degree. So the 5 would tell the 4 to go up to 41 degrees. Measure of angle X is 41. On B, again, we're finding an angle. That's what's missing, x degrees. We're finding an angle, and our only option is to use SOHCAHTOA. We need to figure out which one of these to use to find x. So in relation to x, I have this adjacent leg and my hypotenuse, so cosine gives me my adjacent leg and hypotenuse. So cosine of my angle equals the adjacent leg, 10, divided by my hypotenuse, 27. To find an angle, we always use our inverse. The measure of angle x is equal to the cosine inverse of 10 divided by 27. Grab that calculator. Second cosine, 10 divided by 27. And again, we were asked around to the nearest degree, so the measure of angle x would be 68. Okay, that's it for the end of this lesson on sine and cosine. So you are ready now to work on your homework. Good luck.